Hello and welcome to Circles, round two. We're going to get some tougher ones. Let's look back at the original equation of circles, x minus h squared plus y minus k squared equals r squared. This is the standard form and gives us the center hk and radius r. That's really nice. If we had something like x minus 2 all squared plus y minus 7 all squared equals, say, 83, then we get the center is at 2, 7. And the radius is going to be the square root of 83. That's nice when it's in the standard form. This video is all about what if they don't look like that? What if they're coming out in a different form? And it's like 3x squared plus 18x plus 3y squared minus 42y equals, I don't know, something like 6. That looks ugly. Look at that. That's not in the right form at all. How do we get it there? Well, the secret is actually right in there, that these guys are perfect squares of binomial. Way back in algebra, we did those. Let's look at what they look like. Like x minus 2 squared. What does that actually look like when we multiply it all out? We FOIL there, we get x squared minus a 2x minus a 2x. That's minus 4x plus 4. Good. Another one, x plus 7 squared. Well, that's going to be x squared plus 7x plus 7x. That's plus 14x plus 49. Yeah, look at that pattern that's going on there. What about an x plus 5 squared? That's x squared plus 10x plus 25. Let's try another one, x minus 11 squared. X squared minus 22. You see that double 11? And then plus 121. That's 11 squared. Look at those coefficients there in the middle. They're exactly double of that minus 2. And they're called perfect square trinomials, what we have on the right, because it's a binomial perfectly squared. Well, let's look. What if we started off with x squared minus 6x, and then we try to find out what is missing? What would we have to put in there to complete this perfect square trinomial? Well, let's look at the pattern. We know that those coefficients are exactly double of the guy in the parentheses. All right, so this guy would have to be we're going to try to make x minus 3 squared. So what's minus 3 squared? Plus 9. 9 is that key number that completes what we started with and made a perfect square. Oh, look at that. And we could rewrite it. That's the key. We could rewrite it as x minus 3 perfectly squared. Let's try another one. X squared plus 20x. What goes in there? What's that key number that would complete this square? Well, half of 20 is 10. 10 squared is 100. Yeah, and look at what we just made. We just made x plus 10 altogether squared with the exact proper pattern. Oh, and now look, we can write this as a perfect trinomial square. We took half of 20 was 10, and 10 squared, x plus 10 squared. So this one, if we take the 3 and factor it, it's x squared plus 6x. Let's leave that space there. And then we add the 3, factor it out. We have y squared minus 14y, leave a space, and that equals 6. So what numbers go in there to make them perfect squares? In here we take half of 6, which is 3, and square it, and we get 9. Now notice we didn't just add 9 randomly to a side. We actually added a 3 times a 9. So we got to add 27 to that other side to keep the equation balanced. Ooh. Okay, so the next one. Through y squared minus 14y, we need to take half of 14 is 7. Squared is a 49. We've got to put a 49 in there. But we didn't just add 49 to the left-hand side. We added 3 times 49, which is 147. Oh, good. So now on the right-hand side, when we add them up, what do we get there? 6 plus 27 plus 147. That looks like it adds up to 180. Yeah. Well, what are the other guys? This is 3. But look at what we just did. We just made a perfect square. This is x plus 3 perfectly squared. And then plus 3, y minus 7 perfectly squared. We're almost there. Let's get rid of those 3's everywhere. X plus 3 squared plus y minus 7 squared equals Ah, 60. Look at that. It's now in that perfect form. We know what the center is. The center is -3, 7, and that radius is square root of 60. You could simplify that down to 2 square roots of 15, but that is how we take an equation that looks nasty in and of itself and turn it into a perfect standard form of an equation of a circle. Now we should note that we could have divided everything by that 3 to begin with. The other thing we should note is that if we have the 3 in front of the x squared and the 3 in front of the y squared, if they would have been different numbers at all, this would be an ellipse, not a circle. Good luck!